When it comes to trigonometry questions on the ACT, occasionally you'll be tested on your knowledge of sinusoidal functions. In this video, we're going to go over graphs of the sine and cosine functions. Sinusoidal functions take on the form of f of x equals a times either the sine or the cosine of b times x minus c plus d, where a is equal to the amplitude of the function, 2 pi over b is equal to the period of the function, c is equal to the horizontal shift, and d is equal to the vertical shift. Let's bring this to light by looking at several different graphs of sinusoidal functions. In the top left, we'll start with f of x equals the sine of x. You can see that with the sine function, we actually start at the midline. So we're going to start at 0, and then we're going to rise up to the maximum point. Then we're going to drop down, pass through the midline again, and then lower all the way to the minimum before rising back up to the starting position. This cycle will continue to repeat itself. The amplitude, as we can see, or a, since sine of x has a coefficient of 1, you can see that the amplitude is only 1. That is also the maximum point on the graph. The minimum point, of course, is negative 1. When we refer to the period, what we mean is the distance that it takes to complete one cycle. So we can see that there's a coefficient of 1 in front of the x in sine of x. If we take 2 pi over that 1, we just get 2 pi. So we know the period is 2 pi, and we can see that on the graph. Moving on to the second graph, we have f of x equals the negative sine of x. You can see that it looks very similar to f of x equals sine of x. All we're doing is flipping it over the x-axis. Or in other words, we still start at the midline, but instead of rising first to the maximum, we decrease to the minimum. In the graph on the top right, we have f of x equals sine of 0.5x and g of x equals sine of 2x. All we're doing when we go to those equations is we are changing the period. So we can see that when we have f of x equals sine of 0.5x, 0.5 is b in the function. So 2 pi over 0.5 is 4 pi, so we're actually increasing the period from 2 pi to 4 pi. For g of x, we have sine of 2x. When we take 2 pi over 2, we just get pi. So you can actually see that we complete 2 complete cycles when we go from 0 to 2 pi. In other words, the period is just pi. In the middle on the left, we have f of x equals cosine of x. What you'll notice there is that cosine of x looks awfully similar to sine of x. The only difference, really, is that we start at the maximum rather than at the midline. After that, it follows the same exact pattern. Likewise, when we go to the very middle graph, we have f of x equals negative cosine of x. So instead of starting at the maximum, we start at the minimum. You may notice if you're comparing the graph of sine of x and cosine of x, or negative sine of x and negative cosine of x, that they are related. Cosine of x is equal to the sine of x plus pi over 2. Or you can say that the sine of x is equal to the cosine of x minus pi over 2. In other words, the graph is just shifted by a factor of pi over 2. In the middle right graph, we have f of x equals cosine of x plus 1, and g of x equals the cosine of x minus 1. What we're showing in this graph is a horizontal shift. So the plus 1 means that we are shifting to the left 1, and the cosine of x minus 1 means that we're shifting to the right 1. In the bottom left, we have f of x equals 2 sine x, and g of x equals 2 cosine x. The 2 is just the amplitude. It's the a in the equation for the sinusoidal function. So you can see, instead of rising from 0 to 1, now we are rising from 0 to 2. So we have a maximum of 2 and a minimum of negative 2. And finally, we have f of x equals the sine of x plus 1, g of x equals the sine of x, and h of x equals the sine of x minus 1. When I say that, of course, the +1 and the -1 are outside of the parentheses for the sine. What we're doing here is we are introducing a vertical shift. So in the graphs, we can see that when we have a +1 at the end, we shift vertically by 1 unit, and when we have a -1, we shift vertically by -1 units.